So what we have done in the previous lecture, uh, just a small recap of that. We started application layer and we have seen uh, what kind of different network application architectures can be there. Client server, peer to peer, or hybrid of client server and peer to peer. We have seen some examples also of pure peer to peer architecture, which I promise that I'll be taking later. Uh, then some examples of hybrid of client server and peer to peer. Then we learned the concept of it's not about machines which are communicating, it's more about processes which are communicating, which are running on different end host or end machines. We discussed the concept of socket and how a socket can be addressed or how a process can be addressed when you are making network application. Then we have seen that what constructs a application layer protocol, the types of messages, the syntax of messages, semantics of messages, and then rules how and when a messages can be sent or received. Then we discuss about that different type of network application require different type of underlying services from transport layer. That depends upon the quality of service. Some application can tolerate data loss, some have timing sensitiveness, some require some minimum throughput, and some not. We have seen some examples that what type of services are needed for different type of applications. Uh, then in transport layer we discussed that there are two kind of services, two kind of extreme services. Transmission control protocol service, which is connection oriented reliable transport, provides flow control, congestion control. And on the other hand, UDP, which is just a no frills extension over network layer or IP. So depending upon what type of application you are creating, you can choose one of the service from the lower layer, transport layer. Then we discuss whether we can have a situation where we want some things from TCP but not everything. We want to customize TCP in some sense. Then we actually decided, or we came to conclusion that in that case we need to use UDP at the lower layer, and at whatever extra thing you want to have in your application, you need to code that thing in the application itself. We've seen some examples and which protocol, application layer protocol uses which underlying transport protocol. Then as a first application we have seen World Wide Web and HTTP. Uh, we have seen two kinds of HTTP: non-persistent HTTP, which was used in HTTP 1.0, persistent HTTP, which is in 1.1, which all the modern browsers are supporting. And recently we have HTTP 2.0 also, which is one step ahead of persistent HTTP. If time permits, we'll be discussing that. Uh, we have seen how multiple objects in a single web page can be transferred one by one over a separate TCP connection if you are using non-persistent HTTP, and which was taking lot more number of RTTs. Then we discussed persistent HTTP, and using a keep alive feature of TCP, where the single TCP connection which is initiated or established in the beginning can be utilized for all the objects on that web page. And we've seen some message formats of HTTP request messages. If you want to put some data also with the HTTP request, we discussed about the post method, where entity body can be utilized for sending some form data. And the similar thing can be done by the URL method also, where your small form data can be included, can be appended to your URL, and it is as good as using the post method. Then method types, both in HTTP 1.0 and HTTP 1.1, we have discussed about these. The response messages and what kind of responses we have, and some status codes. of HTTP response messages. Now, there are certain things which we need to discuss beyond this normal HTTP, and I need to listen first of all from you people that what you know about these aspects. Suppose I write certain things here. Uh, the most common thing on our, just a minute, I need to connect my whiteboard. So can anybody tell me what is the uh, difference between static page, dynamic page, and active page on World Wide Web? When you browse your websites, so there are different kind of pages you get: active page, static page, dynamic page. What is the difference among these? So suppose I say static page.
The static page does not have any JavaScript code on it. Like there won't be anything happening. There are no animations, nothing. Just a normal HTML backed by CSS
So you
page.
are giving me a definition of static page in terms of active page or dynamic page. Anyway, so static page, dynamic page, and active page. So okay, you're right. Static page is just like in whatever format, whatever form page is there on the web server, the same page would be transferred to the browser. So there is no dynamicity, or you are not running any code here or something like that. Now this is more interesting. What do you mean by dynamic page? And then the active page.
Sir, in dynamic page, data changes from user to user.
Okay, so you mean to say that depending upon the input of user, some code will run here, some code will run here, and then a page is constructed depending upon the input of the user. That's what you want to say?
Yes, sir, like we store cookies and all.
Cookies is an entirely different concept. Fine, don't mix the things. Okay, so
Okay, sir.
it's as simple as that. Suppose you are visiting a website, say astrology website, so you will input your details, okay, and those details like birth date and birthplace and something. I'm taking just an example where you provide some inputs, and those inputs would be taken by some code here, okay, and then using that input a web page is formed that is individually for you. So this is known as dynamic page. There are different technologies which can be utilized. So what is active page?
So pages which are talking to the backend or APIs constantly.
Mm-hmm. And examples?
Video streaming.
Not exactly. Any other example?
Stock market. We have the stock market, so it shows the real-time data.
Mm-hmm. Any other thing? So what's the difference between dynamic page and an active page?
Dynamic page, the contents is dynamic, but when it's served, it won't change after it's being served.
Mm-hmm.
But active page, the content will may change after it's being sent.
Mm-hmm.
So that is the main difference.
Whether you refresh or you don't refresh.
Yes, sir. Maybe asynchronously.
So even if you don't refresh, it will be sent.
Yes, sir.
Like Cricinfo?
Yes, kind of, you can say that.
So Cricinfo, the commentary you are watching or reading into it, so that particular ball by ball commentary is coming, that is active?
Not sure whether they just send a signal for certain period of intervals, but
Okay, so I'm not going to tell you about this. Maybe on the next lecture we'll see that, and I'll ask this question again. So you need to see some important concepts like CGI, Common Gateway Interface. Okay, then servlets. Just want you to glance through these topics. Then your applets. Okay, then these are all technologies which are, some are old technologies, some are new technologies, some are not used nowadays, some are getting utilized. And then concepts like server side scripting and client side scripting. So can anybody tell me about server side scripting and client side scripting?
Also, validation of a form in the front end, like you are checking the password is containing certain like regex.
So means your web page is having a, like somebody was telling, web page is having a Java script, fine, and that Java script is actually executing at client machine. That's what you want to say?
Yes, sir.
And it is checking whether caps lock is there or special character is there or not. Fine. So this is a very popular technique, client side scripting. And then what is server side scripting? Whatever you have sent, some script is running and accordingly a web page is getting created. Okay. So there are subtle difference between dynamic, active, and all these things. So I just want you to go through all these concepts and just spend 1.5 hours on those concepts, and then you'll be clear by yourself. It's not a rocket science. You are not required to put a lot of effort, but at least you should be clearly uh, able to identify clearly that, okay, what are the difference between these concepts. Okay, so because these are technologies which are utilized with HTTP and HTML nowadays in all type of web pages. Then one more thing which I want you to do, that how a front end like web page front end technology like PHP or any other is connected to a backend database like MySQL. So this is again because when you are making a website or different type of websites, sometimes you require a database also where your scripts can run and sort out the items which have to be put into your web page. Suppose you are searching for something, so somebody has to go back to the backend database and run your query and find out the desired fields or values of those fields and put it in a normal format. Fine. So all these technologies, a little bit of knowledge of every technology is needed. That you have to see that how the modern websites are getting created, how they are connected to like technologies like I'm a bit old fashioned in these. So JDBC, Java database connectivity, uh, and I work on this also, ODBC. Fine. That how connectivity of database can be there with forms, and then that form can come as in form of a web page. Fine. So maybe I'm not very well versed in new technologies because I still work on PHP and MySQL, and our website is on PHP and MySQL. So I'm very well versed with this, but there are some very interesting new technologies, so you should be knowing about that. Am I right? Am I clear? Abhigan? So
Yes.
this I want you to be working by yourself. Okay. Now somebody was talking about cookies, so let's move back to our slides and see what is the meaning of cookies. By nature, HTTP, and by design, HTTP is stateless. So suppose you have opened a website one fine day, and after closing that website, you again open the website. Maybe the browser is same, user is same. You have a login on that website, that's another story altogether, because suppose you are having a login on website in Amazon and this kind of e-commerce website, then obviously your activities will be tracked because you are doing everything in your individual login. Otherwise, even if you are working as a guest, now the e-commerce website want to maintain some information about the user's activity, what user has done, what different kind of products he or she has visited, fine, and whether anything was purchased or not, something like that. In HTTP, this was not possible. HTTP was completely stateless. So how to do that thing? Nowadays, almost all the websites maintain cookies just to track the activity of user, whether the user is having a login on that website or not. It is kind of every website, and nowadays you might have seen in your many websites, if you open that website first time, you'll get to see one message that you have to accept the cookies. Yes or no? Have you seen that?
Yes, sir.
So you have to accept the cookies. Now what is cookie, and what is the utilization of that cookie, and how HTTP can use that cookie for maintaining some state? That is what we are going to see. It's a very small, you can say, a number. Fine. So when, suppose take one example, suppose Susan always accesses internet from her PC, and suppose Susan visited a specific e-commerce site for the first time. When initial HTTP request arrives at that site will create a unique ID and an entry in a backend database for that ID. Unique ID and an entry in a backend database for that ID. And that ID would be sent back to the Susan's PC. And now in HTTP, when the cookie is enabled, cookie header line of HTTP response message, one component would be added, and then cookie header line in HTTP request message would be added. The file is just like a very small file. You can visit your temporary internet files and see there would be many cookies with the symbol @ and those are the cookie files which are kept on your host machine, the user's machine, in this case Susan's PC, and they are managed by the browser. And whereas the backend database is maintained at the website. So you can see that wherever your entry has been made in the backend database at the web server, the ID, or you can say the prime key of that entry, is a unique ID which has been sent back to your host machine, where it is stored in temporary internet files, and browser is maintaining that. So how this is happening, just take example of this. Suppose this is a client machine which is already having a cookie of eBay 8734, there is a server somewhere, and then there is a backend database. What is going to happen? Suppose first usual HTTP request message will be sent to, say, Amazon server, and as and when this request reaches, the Amazon server creates an ID, an entry in the backend database with the index 1678 or a unique ID. Fine. Now when the response is made, so one method of HTTP is used, set cookie 1678. Usual HTTP response will be appended with this set cookie thing, and now the host machine will be having an Amazon cookie also 1678. Now during the stay of the user at the website, all the activity of that user will be maintained in the backend database. Now next time when from the same machine, I mean to say, when the same machine, from the same machine, user again visits Amazon, this cookie thing will be sent. Now getting this cookie thing, fine, now your active pages can be created, because once you get the cookie thing 1678, you know the past activity of the user, and now you can send some sort of recommendation to the user that you visited, are you interested in that, are you. So these kind of active pages, obviously a backend code is also running using your past activity. It will search the inventory, it will search the item list, and kind of send you some recommendation and blah blah blah. And then usual HTTP response message with all the cookie specific action included would be sent back to the user. Even if you do it after 1 week, because that cookie file is available on your machine managed by the browser, again your cookie will be sent to the web server using the backend database entry and your past activity. Some code base will run, and cookie specific action depending upon the code base and some action you have done, active page is created and sent back to you. So this is how cookie works. Now somebody was telling about cookies that time. Are you clear now? Who took that name cookie?
Yes, sir.
Yeah, you clear now?
Yes, sir.
Yeah. Cookie is not active page. Cookie results in an active page. Got the point now?
Yes, sir.
Okay. Fine. Now what cookies can bring? Sort of authorization, shopping carts, recommendation, user session state can be maintained, like in web email. Once you log in it, your login session is maintained for a stipulated amount of time. How to keep state? Protocol endpoints maintain state at sender receiver over multiple transaction, and cookies are actual HTTP messages that carry state. So whatever you are doing is going to be stored in the backend database in form of your activity or timing diagram or something like that, and then that particular cookie, because it's there in your machine, next time when you visit, using that same number, your state, and depending upon the state, possible actions can be transferred to you. Another important aspect which is there in HTTP is web caching or proxy server. So let me stop here and have a small detour, because before doing the proxy server thing, I just want to tell you about another very important thing, that is difference between private and public IPs, and for that I have to switch to the whiteboard. Fine. So what was the problem? Around 1994, they realized that maybe before that, around 1992, they realized that this class A, B, C, another class, this classful IP address mechanism is not going to be sufficient because internet is growing. So they switched to VLSM and CIDR, the concept which you are going to see a bit later, variable length subnet masking and classless interdomain routing, where means we actually we just diminish this concept of classes among the IP addresses, and we have a classless mechanism where, like in class full organization of IP address, the network, the bits in the network are fixed, like in class A 8, in class B 16, and class C 24. So the network and the host bits are fixed in class full organization. In classless organization, depending upon your organization size or a enterprise size, you can choose how many number of bits you can have in network part and how many number of bits you can have in host part. Fine. So the CIDR and VLSM, variable length subnet masking, CIDR came into picture. But even after doing this, around 1994 95, they realized that this IP version 4 is going to be a very scarce resource, and there was a shortage of IP version 4 addresses. And I'm telling you about the time when subcontinent was not having internet, was slowly growing internet. Now, what was the solution? Solution was IP version 6, which is of 128-bit IP address. But the problem is it is very difficult to switch from IP version 4 to IP version 6 on a network which is as large as internet. So they knew that it is going to take some time when you actually can be completely shifted from IP version 4 to IP version 6. Still, if you see on internet, only 70 to 80% of internet is IPv6 enabled. I'm saying enabled, I'm not saying they're actually using IP version 6. But now we have 70 to 80% of internet which is IP. Like even in institutes like IITs and ours, we still use IP version 4. So this is how this is a problem in technology. Technology is, sometimes we say that it is there is a term which we use that is known as ossification, which is used by doctors when certain thing is converted into a bone, is a hard thing which is very difficult to maneuver and modify. So this is the ossification, technological ossification, that if your work is getting done by certain technology, it is very difficult for everybody and all the stakeholders to convince that a new technology is better and you should start using that. So adaptation of technology is a difficult position altogether. Now, what was a stopgap arrangement? Because they knew that IPv6 will come very late. IPv4 is already getting exhausted. So they required a stopgap, I should not say arrangement, it's a kind of a cheat or a jugaad. Now, whenever a technology is made, we always, especially in the network protocol, you will be seeing many times that everywhere in every protocol there would be a reserved field or some group of bits which will be reserved for future, because you don't know the future at that particular point of time, so you just reserve certain fields for future, so that whenever a technological change take place, so there is a empty or a non-used field which can be used. Similar thing was done with this classful arrangement of IP addresses. In class A chunk of address from 10 dot something to something, a chunk of address was reserved, not given to anybody. In class B, 172 dot something dot some chunk was reserved, not given to anybody. And similarly, in class C, 192 dot 168 dot something dot chunk was reserved and not given to anybody. So there was some chunk of IP addresses in every class which was not given to any organization or any individual. Those were kind of reserved for some future use or something like that. Now, these IP addresses were actually utilized in a some kind of jugaad. Now that jugaad is known as NAT, network address translation, or NAPT. In some textbook you may find NAPT, network and port address translation. Fine. So what is this NAT thing? Now just take example of MNNIT. So in MNNIT we have a huge network where every machine which is joined to the network is having one static IP address. Means when you go to hostel, you know that okay, in this room I have to use this IP address, this IP address, this IP address. And at a peak time we have, if you see the number of machines which are added when our institute was there and full utilization was taking place, around about 6 to 8,000 machines, and every machine is having many connections, so around about 30,000 connections, different conversation used to travel through our institute to, we have got two ISPs, internet service provider. One is BSNL and other is National Knowledge Network, NKN. Now if NAT is not there, then for all these machine we have to purchase IP address, which was happening before this advent of NAT. Purchase the IP addresses. What is happening at NAT? That at our gateways we have got two gateways. One is our BSNL. So there is a BSNL router which is connected to some Allahabad BSNL router which is connected to Lucknow BSNL router. Fine. So we are having 1:1 lease line of BSNL and the bandwidth is 1 Gbps. We have one NKN lease line. So we have our NKN router which is connected to Allahabad, then Fatehpur, then Lucknow, and then Delhi. So here again we have 1:1 lease line of NKN and the bandwidth is 10 Gbps. And remember, when you were in the institute, you used to set in your browser the proxy address and the proxy port. Remember, Abhigyan?
Yes, sir.
So some 172.31.100. Some 29.14. Huh? So we have got some proxy servers here for BSNL and some proxy servers here for NKN. Now what is the working of proxy? I'll come later. One interesting thing what this proxy is doing is the NAT, network address translation. In some sense, NAT purely is a lot more different from the proxy technique, but the idea is same. Now what we have done, we have purchased only 32, which may be extended to 64 IP addresses from BSNL and 16 IP addresses from NKN. And currently we have 8 proxy servers, 4 on BSNL and 4 on NKN. 4 on BSNL. Just a minute, I have to take a small break. Okay, fine. So currently we are using 4 IP address for from BSNL and 4 IP addresses from NKN, and using this 8 proxy server we are supporting these 6 to 8,000 machines. So instead of purchasing 6 to 8,000 IP address, we have just purchased a small number of IP address, and that is only due to this technology known as network address translation. And how this is happening, the idea is very simple. So let me take one NAT server. Fine. So what we have done, this NAT server is having 2 LAN cards. One LAN card, which I say internal, is given IP address 172.31.100. Say 14. Now the reserved IP addresses which were not given to anybody in class A, class B and class C, A, B and C, we started calling them private IP address, which can be utilized by any organization freely. Like if you take example, IIT Allahabad internally is using 172, MNIT Allahabad is using 172, IIT Delhi is using 10 dot something, IIT Kharagpur is using 10 dot something. So those IP addresses in private networks like institute network, enterprise network, organizational network can be used freely. So what we have done, suppose what is getting done at NAT is this. So 2 LAN cards, one LAN card is given a private IP. We are using 172.31 range chunk of IP address. And the outer IP, outer LAN card, we say it outer LAN card, will give IP address, the public IP which we have purchased, say from BSNL we have purchased 2212 dot something something. Now all the fellows which are inside are having this private IP 172.31.102 dot something, 101 dot something something something. These are our private IP addresses, and they are connected to this NAT server using our internal institute network. or company network. So whenever we want to send any data out in internet, because this is our gateway, the data has to pass through this LAN card, through this machine, and then it can be transported further. Now suppose take one example. There is a machine inside, like my machine, 172.31. What's my IP address? Let me see, 132.5. This is my IP address. And I want to send some data to Google. And the IP address of Google server is say 182.10.40.6. I want to send data to Google, whose IP address Google server is this. My IP address right now inside institute is this. Now when I send my packet, my source IP would be 172.31.132.5. My destination IP would be 182.10.40.6, the Google IP. My source port would be any source port given by my operating system. Let's take example like 10.20.46. This is my source port number. My destination port would be 80 because we are connecting to Google web server and it listens on port number 80. Now when this packet from this machine reaches to here on the NAT server, or say proxy server also, proxy is also doing the similar kind of thing, what is going to happen? So when I was telling you that these IP addresses can be privately used inside any organization, there was a catch. No data packet having source IP as a private IP or destination IP as a private IP will be routed by any public router. Means a data packet which is having public IP address as source IP address, or private IP address as source IP address, or private IP address as destination IP address, cannot be routed in public internet. So when you want to send data to internet, you have to do some translation. You need to translate your source IP address to some public IP address, because your source IP address currently is a private IP address. You need to convert this private IP into some public IP. So what is going to be done? A table is maintained at this machine, at the gateway router, and this table is going to have 4 fields. Inside IP, inside port, outside IP, outside port. When my packet reaches to the NAT from my organization, from the private network of the organization, the entries are made. So inside IP is 172.31.132.5. Inside port is 102046. Outside IP, I'll take this public IP which is assigned to the another LAN card, which is connected to our internet, which is connected to our ISP. So outside IP, I'll write 212.something.something. And any port which can be assigned by the operating system of this machine, any port, say 205062. This entry is made and my packet is changed. In my packet, source IP is changed from 172.31.132.5 to this outside IP. And now my packet is transferred. Rest other things are not changed because destination IP we want to be of Google, destination port we want 80. Only the source IP and the source port are changed. So instead of source port this, I put this outside port, and instead of source IP this, I put this outside IP. Now packet will reach, having this will reach to Google. Now Google will create a reply. When Google will create a reply, the source IP will be what? Abhigyan.
सर ये 2121
Google's IP, बच्चा. Source IP. कहाँ दिमाग है?
182.10.
When Google will reply, the source IP will be 182.110.40.6. Destination IP would be what?
Destination IP will be
Will be
212.
this 212 point something. Okay. Source port would be what?
Source port will be 80.
80. And destination port will be what?
205.002.
205062. Okay. Now Google will create a reply, and this reply will reach to where? The outer LAN card, no? Because that's the IP address of 212 dot something is the IP address of outer LAN card. Okay. But reply has to be transported back to the originator machine. Now what you will do? Again.
So the NAT will change the IP.
कहाँ से चेंज करेगा?
टेबल
को देख के, इसीलिए टेबल में एंट्री किया था. Okay. When reply will come, so this table will be inquired. Okay, destination IP is this, destination port is this, means this entry is matching. Okay. So destination IP will be converted from this to this, and destination port will be converted from this to this in the reply. Got the point?
Yes.
Now at the same time, if any other user contacts, say 172.31.132.8, so at the same time, if any other user connects to proxy, just a minute, I have to take this call. Sir, namaste. हाँ sir. Right sir. हाँ सर, वो उसका स्कैन हमको भी भेज दीजिएगा सर. लेटर कैसे? ओके सर, नमस्ते सर. थैंक यू सर, थैंक यू. Sorry. Now you can see here, fine. So if any other machine contacts at the same time, what will happen? We can use the same public IP address. But what change will be there? Suppose this conversation is already going on. What would be there? How a same IP address can be utilized?
The port number will
Port
change.
number we can use something else. And at this time, because this port number was already used by this NAT machine operating system, next time any other port number, say 182.50.89, will be given with same public IP address. So in theory, a single public IP address can support 2 to the power 16 internal IP addresses. In theory. But practically it is not possible because you have to maintain so much connection and so much state. Practically a good server can actually handle 8,000, 4 to 8,000 connection on a single IP address. And in this way, the IP address scarcity can be avoided for some time, and it was a good stopgap arrangement. Now all the fellows who were asking question about their home network, who was asking the question? Can you repeat the question now? That you get different IP address or same IP address of both machines?
So let's say there are two users who are connected internally.
Okay, let me show you something first of all. Let me show you. My browser is visible?
Yes, sir.
So if I do show my IP, what is the IP address I'm having? See here?
Yes, sir.
Okay. Now if I do CMD and see my IP address, say, what is that? What is my IP address? Got the point?
Yes, sir. So no, my question was actually different. My question is, when we are in college and we are connected using the same IP, using the same port through Siphon, then how does that work? Basically, we are using the same IP address, 172.32.100.14.
Can you tell me the schematic? So this is your mobile phone, okay?
Yes, sir.
You are running a Siphon here, okay?
Yes,
Then
sir.
there is a Siphon app, okay?
Yes, sir.
Then what you have done settings here, you do write your proxy address,
Yes, sir.
you do write your proxy credentials, password,
Yes, sir.
fine, and then you run this app in tunnel mode.
Yes, sir.
Okay, तुमसे ज़्यादा मेरे को आता है, हाँ ठीक. Fine. Now your whole mobile is actually connected via a tunnel. Fine. And that
Okay, sir.
tunnel is connected to your proxy, and after doing this it connects to, उसमें चूज करने को होता ना कि connect the use the server India server or England server or whatever. देखा है पूरा?
Yes, yes, sir.
Fine. So what is happening after doing authentication with the proxy and connecting once this server, fine. Now this proxy is bypassed, okay? And your requests are directly going to this external server, and this server sometime we say as, you have to study a bit, stun or turn or relay server, okay? So your requests are getting relayed here, at this server, the public IP server. So whatever you are sending through proxy, a header is encapsulating everything and encrypting in tunnel mode, and instead of sending, suppose you have done a HTTP request to a site which is not allowed by my proxy, which is not allowed. So your HTTP request will be again encapsulated in another HTTP request with another IP, and it is going to this public server, where the outer header is getting removed, and you get to know your own HTTP request. You get the reply to this public server, again a tunnel is formed, and reply is sent back to you. This much I can tell you. Okay,
Yes, sir.
fine. And I have given you enough keywords: is, turn, and relay. Okay,
Yes, sir.
after this, this is another thing that is known as ethical hacking, and things like that. Okay,
Yes, sir. Yes, sir.
so I think you have got enough keyword to play with this. I know from where you are coming. Huh? Okay.
Yes, sir.
Okay. Any other doubt? Now let's come back. Let's come back to our original thing from where we have started this, and that was our proxy server. Fine. Now, what is happening is in addition to the address translation, proxy server is doing another thing also, that is acting as a cache. Why it is a proxy server? Because it acts as a server for you and client for the original server. In your browser, as you know, you have to set the proxy server and the proxy port, and all the connections, all the requests will be terminated at the proxy server. There you do the change of, if required, do the change of the IP address, source IP address, and source port. Another thing, this acts as a web cache also. If that page is already available in the proxy server, instead of going to the original server, you can get the reply back from the proxy server. If the object is in cache, cache return the objects, else cache request object from original server, then return the object to client. Means you send the request here. Suppose it is not there, the object will be requested from the origin server. It will be cached here. Next time when you make this, anybody else make the same HTTP request, the response can come back from the proxy server. Any problems you are seeing here in this? If this type of setting is there, suppose I requested some website, and that website was not cached in the proxy server requested on my behalf to the origin server, the web page was came back to proxy server, which is transferred to me, and then web page is cached also. After some time somebody else requested the same web page, response can be given from the proxy server. This is known as web caching. Any issues here?
So maybe these are not helpful for like dynamic and active pages.
That's true. These are not helpful for dynamic. So, but there are lots of static pages, like initial page of any website, no? And that if you see collectively, that is going to save lot of bandwidth. Yes or no?
Yes, sir.
Apart from that, any other issue? Suppose I am requesting yahoo.com or some very static thing all the time, say Wikipedia page. Fine. Wikipedia page of a certain topic that is already cached, that can be given from the proxy server. Actually, there is a cache at your browser end also. You know that or not? first of all your browser cache is searched, then the proxy server cache is going to be searched, and then what is the other issue which can create problems in this case? The problem here is, suppose the original web page changes. I'm not talking about active pages, or even the static page can change. Yes or no? A website designer may change the look, may change the number of links, may change. So this change keeps on happening. And that if that web page is already cached, this cached web page becomes kind of old, which is not updated. Who will update? Nobody will be able to update, and you keep on getting reply from the cache only. In fact, the original web page at the origin server has changed. So this cached web page becomes stale. So how to do that? Abhigyan, got the problem?
Yes, sir.
So I'm not talking here about active pages or dynamic pages, because in any case those would be different. I'm talking about even the static pages, which may change their shape and form during the course of time. So there is a interesting thing, fine, that is conditional get. Instead of having get, we have conditional get. Don't send the object if cache has up-to-date cached version. Specify date of the cached copy in the HTTP request if modified since date. Now, if you have seen any web page response, so in web page HTTP response, there is this field last modified. See carefully, last modified. This page is last modified at this date at this time, and then you have cached that page. Then you have cached that page. Now what is happening? It's a conditional get. You send a request to proxy server. Proxy server will forward this request with this particular construct if modified since that last modified date. If the object is not modified, origin server will send a empty response with a status not modified. Cache will send the request with if modified since construct. Server, if it is not, the page is not modified, then send just a response, it is not modified, and then the cached version will be supplied to the user. Now on another hand, if the object has been modified, then you send the new web page status 200 OK and send the new web page, and a new version will be cached in the proxy server. So in this case, you will be sending all the requests to the server, but if the page has not been modified, the reply will be empty all the time with one status flag that it is not modified. And if in any case it is modified, then the reply will be coming in form of a new modified web page, which can be again replaced in the cache. Fine. So enough for today. We'll stop here, and if there are any questions, you can ask questions. Otherwise, we can stop.